So today, this morning, I will tell you a bit about Python programming language. This course is targeting people who already know a bit how to program, like in Fortran or C or anything. So I will assume that you know some basics, and then I will cover those basics quite quickly. But if you have questions or anything, don't hesitate to interrupt me. We will try to get this dynamical, because if I speak non-stop for 2 hours, you will just die, and me too. Okay, so what I want you to be able to decide today is, having had this training, decide if Python is better for some of your project than the programming language you're already using, or if you want to start a new project. When you start a new project, if you want to use Python or something else. Okay, nothing big. So, that's too big. Okay, so what is Python? Python is a language that was developed in the end of the 90s. It's an object-oriented programming language. The next session today will be about that. It's an interpreted language, so it means that the computer executes it line by line. It means that if you have the Python executable on any computer, the same program will always work. It's the same version of Python, obviously. But usually, if you don't do anything special, it will be slower than compiled programming language like C, Fortran, C++, or anything like that, okay? So there's a plus side and a minus side. The plus side is portability, and that's very good. It's high level, which means that you have functions and modules to do very complicated things. You have modules for linear algebra, you have modules for symbolic calculus, you have modules to access database, you have modules to treat data as blocks, as data frames and things like that. Things that you would have to write 100 lines of code in C, you can do in 1 line in Python if you choose the right module, which is nice because you focus on the algorithmics and what you want to do, and not what things that people have been doing for years in the best possible way, okay? It's dynamically typed. We'll come to that just in a minute, which means that you don't have to define the type of a variable. It always guesses what type it is. Okay. So, too big again. Let's get better. So, why are we talking about Python today? And I will start by the end. It's hugely popular. It's one of the, if you take general purpose languages, it's probably one of the most popular languages, which means it's used in many different cases, from web design to obviously science, games, to anything. And this means also that whatever the problem you have, probably someone else has already solved it for any reason. And so you will find help on Stack Overflow about your issue, which is not always the case if you use another language. So back to the top, the syntax has been done in a way that it's usually easy to read and short and simple, because, as I said, it's high level. So usually you will use functions that do the hard work for you, and your code will focus on the algorithmics. It has an interpreter, which means you can type the commands directly like in a shell command, and you get the output of that command. So you can play, test lines, and see how they work before you write them in the big code. And that's usually helpful if you don't remember exactly how things work, or if you want to optimize something, that helps. The interpreter also includes some help. We'll come back on this, and the huge community that I mentioned. And as I said also, it goes straight to the point. Big things are done by dedicated modules, and so you focus on what is useful for you. And finally, if you do things right, and this is not the topic today, but there's a session about Python for HPC. It allows to be super fast, because the modules that you will use, the high-level module that you will use in Python, are usually written in C or Fortran or anything. And so they are very fast. You will write slow code using fast methods, fast functions. And so if you do it right, it can be in comparable speed as a C code. Comparable, I say, not the same, okay? So for this training session, we will use WooClap. I don't know if you are used to WooClap, but it's very simple. It's a system where I ask questions and you just answer with your phone. So you can just scan this QR code. I encourage you to do it or to go simply to this page. And you should see already one question about your current Python level. So I will wait for you to connect there. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I have 9 answers, we will go. There will be like 5, 6 lookup questions just for me to check if you understand what I'm saying or if I'm just talking gibberish. Okay, that's 5. 50% participation, still waiting. 8, good. Okay, so what I see, so 2 people have never used it and 1 has only read about it. Okay, for those guys, this is very useful. 2 of you have already done a small project with Python. Probably you know half of what I will say. And people who have already used it for their work, I hope that I can teach them something. That's 3 of you. So if you have more advanced questions, this is supposed to be introductory, but if you have more advanced questions, obviously, don't hesitate. The idea is also to determine, I say that for the newcomers, if you will use Python for new projects. So if you have practical questions about your projects, then you can ask me and I will try to help you with that. Okay. So that's for the WooClap. Cool. So Python basics, first, very basic stuff. If you want to use Python during this training course, and I encourage you to do so, there are several ways. One would be to have Python on your laptop. If you already have it, then don't worry, you can use it there. Another would be to use Python on the computing clusters. Any of the user interfaces of the SESI, you can just load the Python module and then run the Python interpreter. And if you don't have access to these or you don't want to, there's the Jupyter Hub web interface, which allows you to run Python online. And if you want to use that, you will have to use your CISM credentials. If you don't have them, then you can ask Damien, he will provide an account for you. Okay? Oh, but you, so the training accounts are not there? Okay. That's true. Then let's see. So who has Python already installed on a laptop? Okay. Who needs something else to use Python? So is there someone who cannot connect to a SESI cluster to use Python with the Python module? Okay, so you will either work on your laptop or on the SESI cluster. You won't use Jupyter Hub. It's okay. If you have issues running Python things, obviously interrupt me and let me know, okay? So if you want to run a Python code directly on your laptop, for instance, the advantage of Python is that it's short. So if you want to do a hello world program, in Java is 25 lines. 5, 10. In Python, it's just 1 line. Print hello world will print hello world. Okay, that's good. So if you want to write a program to do that, you write only the print hello world line in a file. You have to tell the system that you want to use Python. This is not part of Python. It's called the shebang. It's for every single interpreted language. So you put this as the first line, and then you put your Python code. You save it into some file with any name you like. You make it executable. So if you followed the Linux introduction a few weeks ago, you know what this does. It tells the system that you can execute this as a program, and then you run it with // and then the name. I encourage all of you to do it now so that you know you can run one Python program, and then when we do exercises, we don't have to go back to this very simple task, which can be tricky depending on your environment and things. So I want you to check that now, okay? Ah, that's a very good point. Yeah. So yeah, to make that clear, if you use this, you will be into the Python interpreter where you can type Python commands, but this and this are bash commands. So you run it into your bash interpreter on the basic things where you arrive when you connect to a cluster, okay? This is not a Python command, it's a bash command. You run it as you would run date or ls or cd or anything, okay? So I waited for 1-2 minutes just to make sure everybody was able to do hello world. So who has done the hello world already?
Juste les lignes en couleur.
No, this part is just command. Yeah. You want to come? Question sur ton PC. On peut passer ça, on peut utiliser la commande SCP qui permet de secure copy, qui permet de copier depuis ton PC jusqu'à PC. Et dans la doute de ceci, c'est comment on peut passer par le pushing, c'est quand même passer beaucoup d'étapes. Après, il y a d'autres moyens. Tu peux par exemple monter sur ton PC ton répertoire sur l'user interface. Tu peux le faire apparaître sur ton PC pour pouvoir les éditer et ça édite directement à distance. Et ça s'explique aussi sur la doc. Ah oui, parce que Mac, c'est pas bien. Je vous laisserai discuter de ça. Okay, so who has Hello World working? 1, 2, 3, 4, 5. You guys? Problems? Okay. You?
No.
Not working? Okay. Do you need help? Yeah.
You can do it on cluster. It's probably easy. Yeah, you can do it on Visual Studio. Yeah, it works too. Yeah, so you do exactly. Sorry? You do just that. So you use an editor to open a file and then you create this one. Okay. I will continue, but if you Damien, can you have a look with them? So
that's when we redo exercises is ready. Okay, so this was the basics, and as usual, it takes a minute to get used to it. It's normal. So let's come to the basic syntax. So declaring variables, variables are obviously a part of all programming languages. Just give a name, equal, and the value. You see here that I don't give any type like I would do in C, like typing int or str or anything. Number equals 35. Python understands that 35 is an integer. And then these variables contains both the content of the variable, but also the ID that it's an integer. And then when we want to do operation on it, it will do integer operation, okay? You can do floating point with the scientific notation with just an E, which is quite convenient because then you can write the same way you would read it anywhere. And then you can use strings with single or double brackets. Brackets? No, quotes, thanks. And then if you want to use a double in single or single in double, you can also just don't mix them at the beginning of the end. Okay, I will come to that a bit later. Okay. And then once you have defined a variable and any object, you can use the help function on it. So functions on Python are like in other language. You give the name of the function, then between parentheses the argument. For instance, I can do help number when I've defined this, and it will show the help about the int type and tell you what you can do with it. Obviously, you know how to use ints mostly, but this is it. Okay. You can also use dir. It will show the available methods related to that. It's a bit less useful for you. And you can type the name of the variable, and the Python interpreter will show you directly the content of this variable. If you have the Python interpreter launched, you can just type one of those and then type the name of the variable. You will see that you get the content immediately. One of the useful things when you are playing with the interpreter to try to write some basic code or some prototype. Okay. So to remember, no type, Python guesses the type for you. After that, Python will not transfer types like we would have, for instance, in JavaScript, because it's strongly typed. So you will get errors if you try to force something into another type. For instance, if you type 35 between quotes, Python will never convert that to an integer if you don't tell him to convert it. It will always be a string. If you try to do number plus word and word contains 10 between quotes, it will never work, okay? Because Python doesn't want to transform things. It prevents a lot of error. If you programmed one day in JavaScript in your life, you know that it's shitty at this level. Python protects you from that. And that's an example of the help. So if I ask for the help on strings, I get a very long stuff like that with some explanation. And then the list of what can be done on string. For instance, what's interesting for what ends with is a nice one. Check if the given string ends with another string. You have find, so to find a substring, you can format things. You see there are millions of different things you can do on strings, as usual in many languages, but here you have the help directly there. Obviously, this help is also on the Python website, but if you are in the interpreter, you can get this immediately, okay? I use that quite a lot. Okay, so this is good. And obviously, if you work later on object-oriented programming, then your own object can have easily this help defined too. It suffices to put the strings with the help at the right places, but that will come. Okay. So apart from the basic types, which are called the unmutable types that Python has, you have more advanced types, which are extremely useful and are used everywhere in Python. The first one is the list. A list is an ordered set of heterogeneous objects. So the list is defined by brackets like that, and you separate elements by comma, and you can put any type of element in a list, and so it's completely heterogeneous. I have an integer, another integer, a string, and then another list as part of the list. Okay, this element 0, 1, 2, 3, is a list with two elements, 0 and 1, okay? So that's how lists work. If you want to get an element from the list, you can use brackets and then the index of the element you want to get. So my list bracket to bracket is 0, 1, 2. Element will contain A, okay? And you can also start from the end. -1 is the last element. So my list -1 is the list 2, 3 here, okay? That's quite easy to use. It's convenient to be able to start from the end, especially that it's quite often in code you want to get the last element. So I like it quite much. And you can also slice, which means you take a mathematical subset of your list, and you give the first index that you want, and you give the first that you don't want, which is tricky, okay? So it works like that with an open bracket on the right, which means 1 minus 1 means I start at 1 at the element 1, which is the second one, which is 3. And -1 means I don't take the -1. I take up to and not -1. So it will be just 3A, okay? This means everything but the first and the last, which is also convenient, okay? But you have to remember this because it can be tricky in code to remember that you will miss an element if you don't think about it. Then you can obviously change the elements of a list. If I say my list index 2 equals Perl, it will change 0, 1, 2. It will change A to Perl, okay? And the list is now 1, 3, Perl, 2, 3, okay? That's an easy one. You can also modify multiple elements at one time, but then you have to provide a list. If I take the slice, that's an example I should have told you about before. If you are slicing like that, you can remove one of the two. If I don't put this one, it just takes this one into account and it starts from the beginning. If I just take this one, it will go up until the end, okay? It's just, if you don't put anything, it means go all the way. Then if I do this, my list 2 column nothing, it means start at element 2 and take all the rest. And what I do here is that I take the list that starts at 2 and all the rest, and at these places I put this list. So 2 is A, or Perl now, and so I say that Perl and 2, 3 have to be replaced by another list of strings. Okay, so if I do that, I have, as expected, 1, 3, another list of strings. Okay. Note that the size of this list doesn't have to be the same as the size of this list. Okay. You don't have to have the same. It will just tell you that it will put it there. Okay. It will replace everything starting from two and so on. Okay. So using these, you can replace either one element or multiple elements in one list and edit the list that way. That's how lists work in Python. The fact that you can put many different things in the same list and still have very good efficiency is because list is in fact a list of addresses that point to the element in the memory of the computer. So the address of a given element is always well defined, and it's always easy to know what's the content of a defined address. You don't have to know the exact place, okay? So it's very efficient in that way. And then the other very important element that you have, the object data structure that you have in Python, is a dictionary. A dictionary is an heterogeneous list of key value pairs. So you don't have an index and then a value, you have a key and a value. And the key can be, so the assignment looks like this. You use curly brackets, then first key, column, first value, second key, column, second value, third key, column, third value. And if you want to get one of the values, you use brackets again, but then instead of the index in case of the list, you will use the key corresponding to the value you want. So if I want to get the value that corresponds to the key 2. I use 2. Be careful that this is the string 2, which is different from the integer 1 here. So you can put, keys can be anything that is not mutable. So let's not talk about it in detail, but numbers, strings work very well as keys. And then my dict 2 between brackets will return 4, okay? It's exactly like a list, but you replace the indices with the keys of the dictionary. And again, it's built in a way that it's very, very fast to get one of the keys. It's independent of the size of the dictionary. So getting a key in a very big dictionary takes the same time in general, with some exceptions, as taking a key in a small dictionary. So it's a very good way of storing data in many, many cases. If you try to access a key that doesn't exist, for instance, if you are distracted and you put my dict and 4 in between quotes instead of 4 as a string, as an integer, then Python is not happy and it will throw the key error exception, which tells you that key doesn't exist in the dictionary, okay? So that's how you read data from a dictionary. That's how you create a dictionary. And then the next question is how you modify a dictionary. So if I define a dictionary like that, I can do exactly like for lists, my dict bracket at the key 2, the value should be 5, okay? That will replace the value that corresponds to key 2 by 5. Something that I can do also, and that's not in the same way as list, is that I can give a new key and a new value, and then it will just add this key value pair to the dictionary, okay? So if I do that, you will see that for the 2 key, the string 2 key, it will have put 5 instead of 4, and then it will have add a key called integer 2 with a value of 5, okay? So dictionaries don't care about if you add something or if you modify something, it's the same. If you want to modify or add several things at the same time, you can use the update method on dictionary, and then you give another dictionary, and then it will be smart about it. If the key already exists, it will replace the value. And if the key doesn't exist, it will create a new entry in the dictionary, okay? So it's super smart. It will not annoy you with things. So here you see that I had this, then I had this, and it has added the key 3 with the value new entry because it was not there already, okay? So these are the way you modify one or multiple entries in the dictionary. And it looks like strings, but lists, but this is specific to dictionaries. Okay, and those lists and dictionaries are everywhere in Python because they are very useful ways to store your data, manipulate your data. And in general, you will think in terms of lists and strings when you code in Python because it just makes sense most of the time. So just to keep you awake, a small recap. So we have this string, this list, and we want to know what's the result of the slicing that I put. And if WooClap is not that bad, okay, you should see on the WooClap, if you didn't close the tab that you had before, you should see the possible answers. I want you to get the result of this slicing. So we take this list from -5 to 8, and you have to remember the small rules that I told you about. You can cheat by typing to your Python interpreter, but let's not do that. Let's try to do it in your head, okay? Just to check that you followed and you understood what I told about lists 10 minutes. I have 2 answers, 3. 5, 6 more. 6. Nearly there. We have 7. Okay, let's stop with that. 8. Cool. 9. Thanks. So, what happens when I do this slicing? So we'll start with the left. So that's -1, -2, -3, -4, -5, -6. Okay, I won't go further. So we start at -5. So we start at 5, which is okay for everyone but one person. Okay. And then 8 is 0, 1, 2, 3, 4, 5, 6, 7, 8. So we take from this one to this one excluded. As I said, when you're slicing, you exclude the last one. So the final is 5, 6, 7, 8. Okay, if I'm not mistaken, 5, 6, 7, 8. 3 people right, and basically the other half forgot that the last number was excluded from the list, which is a very common mistake in all researchers. So you are forgiven. Okay, everybody does this mistake. I do it from time to time. Don't worry about that. It was just to remind you of this stupid possible mistake. Okay, cool. No, I don't want to change that yet. I want to change this. Okay, so now we've seen the basics of objects. Now we talk about flow control and blocks, because that's the other part of programming. If you want a computer, you want object to put in, and you want to process them with control blocks and loops and stuff. So how do blocks work in Python? We'll start with the simplest one, an if block. The syntax is if, then some condition, and then a column. Okay, that's how you start a block in Python. It's always with a column. And then the content of the block has to be indented, usually by 4 spaces. You can indent another way, but somebody will probably kill you if you do that, because the convention is 4 spaces. So you do an if, you put a column, then you put whatever should be depending on this if. Then you can use else if, as in many other languages, another condition, then another column, and then another block. And finally, an else. If all these are wrong, then you have a final statement, okay? So in all blocks in Python, you have 2 things. You have a column, and then you have indentation to tell you that you are in the block. Indentation is mandatory. You don't have curly brackets to delimit blocks in Python. So if you don't indent properly, the code will do something else than what you do. Okay? You see that the conditions use very normal operators. So this is checking that the value in the variable test is greater than 0. The operator is this, and the result of this is a Boolean value, true or false. Okay, as usual, we'll tell you if this is true or false. Okay, so that's an if block, probably the simplest of all. You can use and or and not keyword to affect the result of the condition. And you can use parentheses around them to, if the expression becomes a bit complicated, you can use parentheses to make it more readable. Python will take into account the parentheses, okay? Then, besides the if block, one of the most common loops in Python is the for loop. Why? Because lists are everywhere in Python, and for is natural to use on lists. So here, if I have a list called animals, which contains 3 elements, a dog, a python, and a cat, I can do for animal in animals column. That means that it will take inside the block here, every animal from the list and put it in the animal variable, which then will be available into the block below, okay? So this will be executed 3 times. if the length of the animal, so for instance, dog in the first time, is greater than 3, so that's len is a function that gives you the length of the string, the number of characters in the string. Then we print animal, and then we say that's a long animal because it has more than 3 characters. And on the other case, we just print the animal, okay? You have to remember simply that it takes the objects from the list and put them one by one into the variable that's there, okay? If you've programmed in other language, you also, and I don't think I have a slide on that, you also have the while loop. While loop is like an if. You have a while, then you have a condition. I should put a slide on that. While x lower than 10. So let's put x equals 0, do something, and then x plus equal 1, for instance. Let's make it explicit. So you have, that's the other kind of loop, a bit less used, but very intuitive too. So while some condition is fulfilled, then we do that. If it's not fulfilled anymore, we stop doing that, okay? That is less used than the for loop because the for loop in Python uses lists and dictionaries, and that works very well, okay? Do you have any question about this small piece of code, or is it quite clear how it works? Do you think you can write a for loop on a list of integer, for instance, by yourself right now? Yeah, confident? Good. I like that. So the for loops are often used with the range function generator, which means that if I do for I in range 10 gives me numbers from 0 to 9, because as for the slicing, it ignores the last element. It also allows you to use a step number, so range 10, 33, 10, 13, 16, 19, 22, and so on and so forth, okay? So this range function is very useful when you use a for loop because it allows you to loop on numbers between two boundaries, okay? It's one of the most used ones besides the lists, okay? So here you see all the numbers, and here you see the same, but with the 3 steps that I put there, okay? So range can take either 1, 2, or 3 arguments. If it takes 1, it's just the end, then it will stop just before. If it's 2, it will be the beginning and the end. And if it's 3, it will be the beginning, the end, and the step, okay? Very useful. And then about lists again, if you want to have the index, so the order of the objects, if I have the same animal, cat, T-Rex, so it's not Python today, okay? I can do for index an animal in enumerate animals, and then it will put the index, so 0, 1, 2, into the first variable, and then the value into the second one, which is sometimes useful if you are working with multiple lists, for instance, and you want to access an element on one list depending on the index on another list. That's the typical way you do that. This is string formatting. I will come to that later. But so I do for index animal in enumerate. That's the point for this slide. Then I get the index and the value. Okay, that's convenient. Then you can also do for loops on dictionaries. And the way you usually do it, it looks a bit like here where you have the index and the value. You can, if you use the items methods on dictionaries, you get the key and the value. If I do that, then inside the for block, I get key, which is the key. So key and value are first and Monday, and then second and Tuesday, and then third and Wednesday. And then I can go through the dictionaries that way with for loop, okay? With the items that I have here. Is it okay? Do you understand this, this system for looping? And then sometimes you want only the keys or only the values, less often, but still. The keys is just for key in my dict. That's how it works. You don't have to put anything. By default, a for loop on dictionaries loops on the keys. It's super fast and efficient. sometimes it's enough. And you have, besides the items that you have here, you have values, which allows to loop only on the values. That's far less frequent, but you sometimes have to do that too. So my dot values will take all the values from dictionaries, ignoring the keys. And then you have, I had a side of why, I forgot about that. Good. You have other control flow statements, flow control statements, sorry. For instance, the why that I told about. And you have, as in C, break and continue. Break gets you out of the loop. It can be used as a condition. When you reach some condition, you get out of the loop. If you are working with while, then the break condition will most likely be here. But if you are working with for and you need a way out in some cases, then you will use break. With an if, you will use an if to check some condition and then have a break below. Okay. Continue is different. What it will do is it will ignore everything below the continue and get back to the top of the loop. If you have a continue somewhere here, then this line will not be done because it will always get back to the top. Again, usually you have a condition above the continue to check in which cases you don't want your loop to work on these lines. Okay. So those are very useful, but most of the time you can avoid those with a proper definition of your for or your while loop. There are exceptions, and there are very well justified exceptions where it's very efficient to do it that way. But in many cases, you can avoid that. So a small recap, very simple one this time. Check if you followed the things I just said. So I have this simple code, if test greater than 0, print first, print second. And I want to ask you, when will the code print second? And then you have several options. First is never, second is always. Third is if test is greater than 0. If test is 0 or lower. And finally, the code will always crash. Just tell me what you think, and we'll come on that just to check what you understood. I know I'm talking very fast, so if it's possible you missed a minute and then you forgot something important. It's looking good for the moment, but only half of you answered. Nine is my limit. I stop at 9. Okay, so most of you, 7 out of 10 answered always, which is right, because we are out of the block, and then it's at the same level as the if, so it will always get there. Okay. Some people said, 2 people said the code will crash. I'm interested in why you would thinking the code would crash. Can someone tell me why they thought the code will crash? I will not bite. Yeah.
I was not sure if you needed to first initiate the variable test to some value before.
That's exactly right, and this is just a small subcode. You were perfectly right.
Okay.
This code only would crash because test is undefined. You were completely right. But it's my question what that was bad. Okay, and 2 people thought it would never get there. Okay. Okay, cool. So now, is everybody comfortable with the fact that it will always be printed because it's outside of any block? Cool. Thanks. But you were right, the code as it is now would crash. So I think it's a bit less than 1 hour, so it's time to do a small exercise, which is not that small. It's a serious exercise, which has some practical application, so let's be happy about that. So I want to get a list of the prime numbers, and one of the oldest algorithms to do that is it's from a Greek philosopher, but I forgot who that was. Okay, let's not think about Greece. Let's think about Python. So we have a list that we build with that list of range n plus 1. It's just a list of number from 0 to n. Okay? And then we want to replace in that list all non-primes by the Boolean false. Okay, so if we go from 0 to 9, we'll have 0, 1, 2, 3, which are primes, false because 4 is not a prime, 5, 6 is not a prime, 7, 8 is not a prime, 9 is not a prime. Okay, we want to build that, but up to a very big number, obviously, because up to 10 we don't care. So the algorithm is quite simple. You start at 2, and then you use a loop to mark all multiples of 2 as false, because obviously the multiples are not prime. Okay, and then you go forward by 1, you go to 3. 3 is not marked as false because only 4, 5, 4, 6, etc. are marked. And then you go to 3 and you mark all the multiples of 3 as false. Okay, and then you go to 4. The number is already marked as false, so it's already a multiple of something. So obviously all its multiples are non-primes too. Okay, so you skip it completely, and then you go back 1, you go forward 1 again, and you arrive at 5, and you mark all the multiples of 5 as primes. Okay, and then when you have reached square root of n, since you use the multiples, you should have already marked all the multiples as non-primes, and then you have the list of primes that's built. Okay, so the exercise now, and you can take 20 minutes if you want, think about it, is to build this algorithm and check that you get the primes. Just take a number like 20 to start, just not to get big output, and try to write a program ideally write it in a file because it's easier to execute. If you do it in the Python interpreter, it's multi-line, so it's annoying to do again and again. And then if you need help, ask me. And I hope in a few minutes, 20, let's say, you all have something that works. It will ask for 2 loops, okay? As you see, one to loop on the numbers, and then to mark all the multiples as false, okay? So start, ask us if you need any help, and I will anyway give solutions afterwards, obviously, to help you. You obviously have permission to cheat and to work together if you would like. So how is it going? Are you stuck with something? Are you just making progress? I'll give you five more minutes, hoping you can get something that's satisfactory for you, and then I will go through the possible solutions, okay? Okay, I will stop you there because otherwise we won't be able to cover the whole subject. Who has something that they are confident would be done or nearly done? Okay, cool. Shows what you like. Did you use for loops or while loops? While, for, or both. Okay, cool. So I will show some solutions. Where is this mouse? Oh. So a simple one based on the while loop. So I define my primes as the list range n+1 as I put in the slide. Then I start at number equals 2. And while my number is smaller than the square root of n, you are not, I didn't speak about math, so you didn't know about that, it's just to make it quicker. The number will be basically the index in the list, which is equal to the value in the list because the list has 0, 1, 2 until n, so it works. If the value of the primes list at number is not false, then I go to double this value. And while I'm not at n, I will mark all the subsequent multiples as false, okay? I mark as false, I go up by 1, I mark as false, I go up by 1, etc. Obviously, I could have put this there to go 1, this there, sorry, to go 1, to go further. First, there are plenty of ways to solve that, okay? This is one solution. And if I do that, and I get all the primes up till 100 here, I think it works. Didn't check the exact numbers, but it's supposed to be simple. So you have two loops, one to cover the range and one to mark the multiples, okay? Then if you want to be shorter than that, you can use, for instance, a for loop to loop on the primes list. So I do a for loops in the primes using slicing to start from 2 and going to the square root of n. I use an int function here again, just for the example, you didn't know about that, so that the beginning and the end of the slice are integers. Then if that number is not false, I do the exact same as before. I just mark them as false, okay? And this does the exact same. Then, since I have two loops, I can also try to replace the second one by a for loop. So I do the same as before. Then, if it's not false, for all the temp numbers starting at 2 times my number until n+1, and the step is the number itself, then I mark these primes as false. Okay, I use the range to start at twice my number. So if I am 2, I start at 4. I go up till n, and I advance by 2 each time. And then I have basically a 4-line solution to this, 1, 2, 3, 4, okay? With a for loop. So the lesson is that usually you can do things a bit quicker with for loops and while loops, but the syntax gets a bit more tricky, okay? And then finally, you can even make it shorter because, as I showed you before, you can modify multiple elements of a list at one time if you use slicing on the list. So if I do primes starting at number 2 to n+1 going forward by a step of number, I can put that equals a list of false, and it would put false at all the positions that I give, okay? And so I build this list by using false times the length of this, and I plug it in, and then it marks everything as false in 3 lines, which is cute. It works. Obviously, there are even shorter solutions, but this is something reasonable. And then if you want to do it in a cleaner way, you will use NumPy, because NumPy allows you to mark this as false, and it will mark every element as false, and you don't have to give a list on the right, and then the syntax is a bit cleaner, okay? But it's still a 3-line solution. So that way you have various solutions. The simplest one and the most obvious one is to use while everywhere, but just to show you the example, if you replace it by for instead of while, you get a shorter solution and still a very readable solution, okay? So this will be online for the moment. The version of the presentation that's online is the one from last year, so it doesn't have these solutions. It's not there yet. You didn't do your job. The one from, sorry, this one? I sent you this one? No, I didn't send you this one. No. Yeah, that's again. Okay. So I will send this to Damien at the end of this session, and you will get the solutions if you want to have a look at that. Okay, I'm already super happy that part of you got a solution that they like, and for the rest, just have a look at the solutions and see if you understood that. Okay. Should we take a? Do you usually have breaks, Damien, in these sessions? It's up to me. That's hard. No, sorry, I won't have a break because otherwise I fear I cannot cover the whole thing. So let's continue functions now. So if you have programmed in any language, you know about functions. Functions are a way to gather some code in a structure that you can reuse at will in your code, okay? They are very important because you don't want to type the same code multiple times. That would be super bad. So if you have to do the same thing multiple times, you have to factorize it into a dedicated code piece, which is the function in this case. So the keyword to define a function is def, which is weird. One of the things Python does in a weird way. Def, the name of the function, then the list of the arguments to the function, then the usual colon, and then inside the block, whatever you want the function to do. So what are the role of these things? The arguments are values that will be passed to the functions to be used inside the code. If you have programmed any programming in any programming language you know about it, okay? And then at the end, you can use a return statement so that the function sends something out, so that you can do, for instance, my function calling the function and put the output of the function into something. The something that will be put into this variable is what is given by the return keyword, okay? So that's the basics. You have a function, you put arguments in, you get return value out, okay? That's how a function should work. Then in Python, there are a few subtitles. You can have arguments with default value. This means that if I don't give a value for argument 2, the program will assume that the value is 0, okay? This also means that I have to give a value for argument 1 because the program won't assume anything if you just tell you, I don't know what to do with that thing, okay? So that's one. And because of that, the ones that have default value always have to be on the right, and the one without has to be on the left, so that when you call things, Python knows if you are in the default value or the non-default value. So no default value left, default value is right, okay? Then when you call it, you can call it using the name of the argument, which is usually very nice, because if you have meaningful names for the variables, you can use them, and then the user will know which argument it corresponds to. If I gave 3 values for argument 1, argument 2, argument 3, then the user is not aware what is argument 2, argument 3. If I say argument 3 equals 7, then I write in the code that I want explicitly the argument 3 to your value 7, and it's more readable, okay? So you see also here something nice. I didn't tell about argument 2. I skipped completely argument 2. If I use my argument using the name of the argument, the order of the arguments has no importance. Okay, I can get them in any order, which is nice because usually if you have, for instance, you would be using NumPy that I used before for linear algebra. You have functions with 10 arguments, all of them optional. You don't want to remember the order in which you have to give them. That could be a mess. Okay, and it's a mess in many languages. In Python, you just give the ones that you want. The other have default values, so you don't care. And you give them by name. So you say, for instance, format equals that, or color equals that. And you don't have to remember that color is the 5th argument. You have to remember that you die, okay? So 2 rules. Arguments without default value on the left, with default value on the right. And when you call the function, argument that you call without the name on the left, argument that you call with the name on the right, okay? It's easy to remember because it's the same thing, because you have the name and the value right beside the other. So the ones that don't have this syntax go on the left, and the ones that have this syntax go on the right. Otherwise, Python doesn't know who goes where, okay? So that's how it works. If I do that, I have a function that prints basically the value of the arguments. Then if I call it with argument 1 equals a string, argument 2 I don't specify, argument 3 equals 7, it will tell me that argument 1 is a string, argument 2 equals 0 because I didn't change the default, and argument 3 equals 7 because I gave the value here, okay? It's very nice syntax, very useful, simple and efficient. Any questions? Okay, so now a bit about strings, because you always have to work with strings. You have a basic operation, which is a plus operation between strings, just concatenating string, okay? This, hello world. If you have a list and you want to join things, you can use the join method on the string, which takes a list as an argument, and we take all the elements in the list and join them using the string that is before the join method, okay? So this will write cat plus dog plus Python. You will probably use that using a comma if you want to write CSV files or stuff like that, even though there are better ways, okay? And you have the reverse, which is quite nice, which is split. Split takes a string and split it in words and lines. So basically, if I do that, I have my sentence equals cats like mice, and then a new line. If I strip it, so this strip method will remove the extra space and new lines on left and right to keep the basics. And then split, we split into words. So my sentence was a string containing this. And then if I do my sentence equals my sentence the split, it will split that and put the values into my sentence, which is now a list, okay? I put the new values into the old variables. So the variables contains a string, and now it contains a list, and the list has the word cats like mice. And another small subtitle is that split can take an argument, and then if you split, so the default argument is white space. If you put another argument, then it will split on that new argument. So in that case, if I could have put the character E, for instance, and then you could have cut here and here instead, okay? And remove the E. A bit more about strings, because those ways of using strings are mostly annoying. Mostly, if you use strings, you will use templating. So you will have a string that serves as a template. This string has curly brackets that serves as holes when you want to put values in. And then you can use the format method to say what you want to put into the holes. So out equals my string.format cat happy. We'll put cat into the first hole and happy in the second hole. It's ordered arguments for the method, so it will put them in the same order, okay? So the cat is happy. The cat is happy. It's simple. Then when you do that, it's nice, but still, if you want to use the word cat in the template multiple times, for instance, you have a web page, and the name of the user will appear 5 times on the web page. You don't want to remember that it appears at the 1st position, then at the 6th position, and at the 27th position. That's awful, okay? Then you will use a dictionary named argument instead. So if you give names into the holes, and then in the format you use named arguments like that, what it will do, it fills the holes that have the proper name. So in every time there's an animal hole, it will put cat, and every time there's a status hole, it will put happy. This is far better. And most of the time you will probably use that instead, okay? That way, the cat is happy, really happy, fills all the status holes with happy, and everything works, okay? That works too, but it's less readable for the user, so you have to think what makes sense for you, okay? And finally, what is very Pythonic, I would say, in a way to do that, but we'll see a bit of details about that, is that you can, using double star, transform a dictionary into a list of arguments. So if I have a dictionary where the animal key contains the value cat and the status key contains the value happy, I can use format ** mydict, and it will turn this into this, and then it will do exactly the same. Just a way of specifying the values, taking them from a dictionary, okay? I will explain this double star syntax in a minute. Okay, but you should remember the most in this slide, this is the main thing, named arguments for templating, okay? Then now, since Python 3.6, so for the last at least 4 years, let's say, we have F strings, which you will see everywhere. Basically, you can skip the format command. You put an F in front of the template, and it will look into the global scope for the for variables that have the names that you put into the holes. So it works exactly like a format with a named template, except that instead of looking for them into the format method, it will look for them into the scope, okay, into the scope of your program. It's fast, inefficient, and most of the time it will work well. So you can skip the format thing in many cases, okay? And the advantage of this also is you can easily put code inside the brackets. So here I use status times 3. Status is happy. Status times 3 is happy, 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 happy. Status.upper, put it in uppercase. So if I do that, you see that here it has replaced status times 3 by happy, 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 and status.upper by happy uppercase. Okay, this is convenient. Obviously, you don't want to put too much code into there because you don't want to put the code into the template because then it's unreadable. So most of the time you will put the code outside, but the upper here is a standard use case where, yes, I have a variable, but I just want to use the uppercase of that variable here. You don't want to put the variable upper outside and then put it in, you just transform it here, okay? And finally, about string, a very simple thing is that there are centering, left and right alignment ways. So this means align the string in the middle of a 30 space, empty space, align right on a 30 space, align left on a 30 space block. You also have formatting for floating numbers. For instance, dot to F means keep 2 figures after the dot, and this means use 6 characters in total and keep 2 after the dots, if my memory is correct. So if I do that, yes, so 1, 2, 3, 4, 5, 6, and zeros on the left, so that it fits. Those things are useful if you want to have nice columns of numbers that are aligned with the dot to be more readable when you show them to your advisor, because otherwise, you know, all professors can treat numbers if they are not properly aligned. That's when you're. And just so you know, there's an old formatting with the % sign that's dating for Python 2 and a long time ago. That you will still see because it's still supported in Python 3. Some people still code like that. They put %, then the type. So %s means that you expect a string here. %i means that you will expect an integer. Then %, then the list of values. This is old syntax. You shouldn't use that because it's less flexible and there are very few situations where it still makes sense. I think the login module still wants that, but that's the only one I know. So don't use that, but expect to see that into some old people's code, old like I'm old. Okay, so I would say now you can do most things in Python. You know variables, you know control flow, you know basic string stuff. You can do basically everything that you need to do. But then I will go into more details into the useful things that you have in Python, the shortcuts you can do, and the modules that you want to use and things like that, okay? So we go a bit further. I hope you can, the ones that are already working in Python can learn a few things again. So first thing I would say is if you are not doing that yet, use an IDE to code in Python. You can work in Vim, you can work in Gedit, you can work in whatever you want, but you will miss a few things. You will miss the syntax highlight, the syntax check, some completion, some refactoring functions, some debugging stuff, the auto versioning and stuff. So I say you will miss that, but it's not true. If you use Vim, like me, you can configure it to have syntax highlight, syntax check, completion, debugging, and versioning into Vim. That's some work. It would take you 2 days to have it to work perfectly, but then it's very convenient. The thing is, if you use Visual Studio Code, it will take you 21 seconds to have it work the same way, and you can use Vim commands into Visual Studio Code. So when I realized that, I dropped Vim for my Python code nearly forever. Okay. So the good development environment that I know, Visual Studio Code is super easy because you have all these features that you just have to download and they work out of the box. So that's very convenient. On the other hand, it's a bit heavy as a software. Spider is a very lightweight one that does big part of those things in a nice way. I don't like it that much, but it's lightweight. You have also PyCharm, which is heavyweight, but it's dedicated to Python, so it does everything out of the box. And Sublime is quite nice because, as the name implies, it does all the aesthetic very, very nicely. Okay. My choice is Visual Studio Code, but feel free to take whatever you want. You can use Vim. I did that for a while. I still do that if I work on the company cluster from time to time because it's easy to start Vim on the cluster. But if you use, for instance, Visual Studio Code, you can open your remote files directly from the cluster. It gives gray hair to some people because it puts some load on the cluster, but you can do that, okay? But please, if you have a big project, use some of these because they help a lot. For instance, Git is included, so you don't have to think about branches and stuff. Git is already there. It tells you, I modified this file at that line, that line, that line since the last commit and things like that. They're very convenient if you are coding. Okay? And always use Git. If you are doing coding and you don't use Git or anything, no, there's only Git now. Everything else is dead, right? Yeah, Mercurial is dead, Bazaar is dead, SVN has been dead for long, CSV doesn't exist. Yeah, there's only Git. Is somebody using something else than Git now? No. Okay. Who is not using Git at the moment? Okay, you probably should.
I know.
Okay, good. So I was talking about the star syntax and double star syntax. The way it works is you have a function and you want to give it a number of arguments that you take from a list. If you have a list that contains dog and cat, if you call a function with star and then the name of the list, it's just a pure equivalent to this. So it will take the list, it will split it, and put the arguments one by one as arguments of the function, okay? Same with a dictionary. If you have a dictionary that looks like that, and use double star, then it will be replaced by a call to the named arguments, animal and toy, with the values. So the keys are used for the name of the arguments and the values for the value of the arguments, okay? So those are very convenient, and they work both ways. If you define a function with those, so the names of the variables here don't matter. Those are the conventional names. We'll make it bigger because it's... So then whatever is given as positional arguments we put in a list called args, and whatever is given as a named argument will be put in a dictionary called KW args. If I do that, so I call the function with post arg1 34 and named arg equals named as argument. You see that args contain two values, post arg1 and 34, and KW args, the second argument, contains a dictionary with the key named arg and the value named, okay? This allows you to define functions that can have any number of arguments. All the arguments are put in a list. For instance, the print function that I use everywhere, here, you see it takes two arguments. You've seen in the past, it can take one argument. It can take 1,000 arguments if I want. I don't want to code a print function with every number of arguments. The print function is coded using this to allow for any number of arguments, okay? This is quite useful in many cases when you realize you might want to have the function that takes an arbitrary number of arguments. Okay. Small recap about functions. I should have put it a bit earlier, but since there are stars, probably is a good place. let's do that. So I give you a list and a dictionary. I give you a function that's defined with two positional arguments and two arguments with a default value. So two arguments without a default value, two arguments with a default value. And then I have these 6 calls. I want you to tell me which ones are valid. So which of these ones will not give an error. So to remind you, the two important rules, the most important rule is usually that the arguments with a default value have to come on the right. The argument with a name, sorry, have to come on the right of the arguments without the name, okay? That's one of the important rules. The other ones just come from this mostly, okay? So, I have 2 answers now. Three answers. I know it's been an hour and a half, so you're getting tired, but be brave. You can do it. I want at least 7 answers. Still 5. I expect a few more, guys. All right. Okay, let's have a look. So, as I said, arguments with names should go on the right of arguments without names. So this is okay, because I give the value for R1 here, for R2 here. I don't give a value for session, but the value is written here. And daytime, I change it, it's okay. So this one is okay, and everybody but one agreed on that. Okay, let's say it's okay. This one fails because I have the 42 that comes after the daytime equals afternoon. And then Python doesn't know which variable it has to put the 42 in, okay? Arguments without the name should be on the left of arguments with the name. Everybody but one person agrees on that. So for me, that's a good result. This one, I give the SESI value to arg1. I give daytime equals afternoon there. I don't give a value for session, so it's okay, but I don't give a value for arg2 either. And then Python doesn't know what to put into arg2. So it will complain, okay? So this one is bad. This one is bad too, because I give all the named ones from the dictionary, D, before the positional one without the names on the right. So this is super bad. This one is good because I give 42 and SESI first. So 42 goes into arg1, SESI goes into arg2. I don't give anything for the other ones, but they already have values. That's good. 7 people got it right. Fantastic. And then the final one, star L star star D, works perfectly because you give 42 and SESI to arg1 and arg2, and then you give session equals Python instead of C++, and then you don't give anything for daytime, but that's okay because it already has a value. Okay? Does this explanation convince everybody that my answers are correct, or do you still have questions? Let's say you don't have questions anymore. This two screen stuff is annoying as well. Okay, I should do one. So these are solutions. Then one thing that I like quite a lot in Python is list comprehension. So that's, if you've programmed in a lower level language, it's probably completely new. It's a way to build a list from just a single line. So if I do this, bracket x.x for x in range, it automatically does a loop on range 10. And for each x, it puts x squared in the list. So this returns automatically a list containing the squares of number 0 to 9. Okay? You can put it in a variable and reuse. And with a single line, you didn't have to do a for loop. You directly get a list, which is nice. And which is nice also, here I put x squared, but I can put anything. So if I have strings, if I have strings, I can use the upper, for instance, method and have a list that corresponds to each of these things, but in uppercase. I can also filter. So I can do it only if there's an O in the beast, okay? So if I do that, the first one, beast.upper for beast in beast, will make a list of the same as that, but uppercase. This one, we take that and take only the names that have an O in it. So it will contain only dog and Python and not cat, okay? So this is called filtering because you only do that, you only keep them if something. And this if usually uses the value that you have in the for loop, okay? Makes sense. You also have another nice thing you can do. You can go through multiple lists at a time inside the for loop. You can do that in a list comprehension like this. You can also do that in a normal for loop, but I will show it here. If I do zip of two lists, it will go one by one into the two lists at a time, like they were in a zipper, like on your jacket, okay? So if I have a list of toys that contains ball, frisbee, and dead animal, a list of beasts that contains cat, dog, and Python. If I do for A, comma B in zip beast toys, then A will contain each of the entry of beasts, and B will contain each of the entry of toys, one by one. So in the first iteration, A will contain, so it's the beast cat, and B will contain ball. Then in the next iteration, A will be dog, B will be frisbee. And in the third iteration, Python will be A and dead animal will be B, okay? So it's zip in the sense of a zipper merge, and you just take both lists at the same time. And you can also zip 3 or 4 or any number. It's also a function that works with the star system. So it can have as many arguments as you want. Obviously, you want the number of variables here to be the same number as the number of lists here, otherwise it will complain. It's quite happy if the lists here don't have the same number of entries. It will just stop at the shortest. It will stop after that. But most of the time, we will want to have the same number. Okay. So if I do that, then it will create a list. The cat plays with the ball, the dog plays with the frisbee, the Python plays with the dead animal. Put that all in a list, and I use the formatting here with the dot format method that we saw a few slides before. Okay. You can also use, so I showed you an if on the right to do a filter. You can also use if on the left to have multiple processing solutions. For instance, here I use x squared if x modulo 3. So if x is not divisible by 3, or if it is, then I keep x for x in range 10. So it gives a very weird stuff. So it gives 0, 1 squared, 2 squared, 3, 4 squared, 5 squared, 6, 7 squared, 8 squared, 9. Okay, because if x modulo 3, so the remainder of the division by 3 is 0, then this if is false, and so it just keeps x. It does x squared, otherwise it doesn't. Okay. So that's different from the filtering that I did on the right. It's an alternative value on the left. Okay. And you can also do 2 loops in the same list comprehension. So I can do for A in something, for B in something. And then it's 2 loops, one into the other. So it will give so if I have A, which is blue or red, and B, which is car and balloon, then it does blue car, blue balloon, red car, red balloon. Okay. Yeah.
Is the question mark symbol valid in Python? So because, for example,
for this, you mean?
Yes.
No, I think it doesn't work. So the ternary operator that you are thinking of is written like this everywhere in Python. So you can use it to define a variable, for instance, and it's, to me, more readable than the ternary operator. So yeah, I don't think it worked at all. You don't think. In the past, you had to use an and or, but it's dead for long. So final woo clap, I guess, for today. Let me look at the time. Let's keep that one for this time so that we have more time for the exercise at the end. So reading files. So now we will come to things that you can use in your daily job. So to open a file for reading, you just have to use the open function. You give the path to the file, or the name of the file if it is on the current folder, and it returns what is called file descriptor, which is a pointer to access the content of the file. You can read one line, so you can do f.readLine. It will pick the first line of the file. Okay. If you want to have all the lines of the file in a variable, then you can do f.readLines plural, and then it will return a list, and each element of the list will be a line from the text file. This is about reading text files, or any file that has text. For binary files, a bit different, and then we won't discuss it right now. Okay. Usually, you don't do that exactly. What you do is use the with keyword to enter a context manager, which means it's exactly open something as f. It creates a file descriptor f for the file house.csv. But it ensures that if you are inside the block, the file is open. And when you leave the block, the file will be closed properly. So this is how you want to open files usually. And then when you have this, then you can do a for loop on f, and it will do exactly the same as the read lines that I showed before. So it will give you the lines one by one. The difference is that it will not load the full file to the memory of the computer. It will just load one line at a time into the memory of the computer, which means that if your file is 4 gigabytes, you won't fill the memory of the computer. Okay, that is usually a lot better than this if you can avoid having all the lines in the memory. Yes, I think I give everything. So the context manager with the with keyword is something that is used mostly for things when you have an entry and an output. For instance, if you want to connect to a database and close the connection to the database at the end, you have a context manager to do that. If you want to connect to websites, some things like that, then you have a context manager. Okay, you won't use them a lot, but the most time you will use it is to open files. Some of my favorite Python tricks. You have the in keyword, which checks if something is in something else. If cat in my string checks that the cat string is somewhere into the string here. Okay, that's very simple and can be used in many cases. If you want something more smart, you have regular expressions that I will mention later. But for the basic cases, this is nice. You can also use it on lists. So if 8 in my list, then it says it's found. It will go through the list and check if the number 8 is in the list. Obviously, this and this will depend on the size of the object. If you have a very long string, like the last book by some of your favorite authors, obviously it will take a while. It could take a while if the word is at the end of the book. Same thing here. If your list has 1 million entries, checking will take time that is proportional to the size of the list. Okay, so use carefully if you have big objects. In dictionaries, if you use it, it will check the keys of the dictionaries. So it's not always super useful, but it might be because it's independent of the size of dictionaries because of the way the dictionary is defined. So you can check in a way that's not dependent on the size of the dictionary if a key is already present in the dictionary. It's good. Okay. Another thing that might be super useful is that most things are true or false in an if condition. If you have an empty list, if you do if my list, it will only go there if the list is not empty. For strings, it's the same. For numbers, 0 is false, and something not 0 is true. Or for ints, 0, non-zero. For dictionaries, empty dictionaries, non-empty dictionaries, and things like that. So you can easily have conditions that are shorter if you are working on these objects. And as we discussed a minute ago, you have the ternary operator. So you can do myvar equals dog if test is greater than 15, else cat, which means that if test is greater than 15, you put dog into myvar, else you put cat into myvar. That's for a fairly readable. But that's exactly the same as all the ternary. One thing that might be super useful is if you don't know if a key will exist in a dictionary, which happens a lot. For instance, if you are reading a configuration file or a data file from a user, you don't know if it will be defined in the right way, or you can use the get method, which means take this dictionary, get the value for the key Python, and if there's no key Python, then give me that, okay? So it's default value for dictionary, and I use it basically every day. It's one of the most useful functions on dictionary. Another thing then, this is just listing the wonderful things of Python, so it goes a bit fast. Just I want to amaze you. Okay, you can do multiple assignments. So you can do AB equals something something. If I have A equals Python B equals dog, I can do AB equals B cat, and then A will take the value of B, which is dog, and B will take the value of cat. Okay. You have to remember when you use that the right side is evaluated first. So they take the values for all this, and then they put them there. So you cannot have a loop dependency or anything. It's always well defined. You define everything on the right and you put them on the left. This means that you can swap A and B. I could have written here AB equals BA. It would have estimated on the right and then put on the left, and you swap the two values easy. Okay. So this is the default toy. This is the cat as expected. And then using this, like it's written here, you can also return several things from a function. And then if you use the function, you use two values and you put the two values that are returned from the function into the two variables, okay? There are not many languages where you can do that properly. And it's very convenient because it's quite often that your functions want to return several things. Yeah.
And on line 3 of the code, if you only specify like var A.
If you do that, then what it will do is create a list and put it in. It's not a list, it's a tuple. It's a kind of list that's not mutable, but it will put it in variable. Very good question. So you can do that too. And then you have A0 and A1, for instance, to access the two values. Okay, so lists you can do also if you are doing your for loops on lists, then you can use the reversed and sorted functions on your list. Reversed will naturally take them from the right to the left. Okay, nothing weird. Sorted will sort them in a natural way. So sorted animals will be animals sorted by alphabetical order by default. You have to know that the sorted function can take additional arguments to specify how you want to order. Okay, and there you can do whatever you want because there's a very flexible way. For instance, the default sorts alphabetically, but takes the uppercase first and the lowercase after. If you specify a key that puts everything lowercase, then it will nicely sort them in other order. Okay, that is the way it's usually used. So here, sorted does cat.python because cat comes first in the alphabet. If I put uppercase somewhere, then I will have code inside. Something that's also super useful is the any and all. Any and all take a list or anything that has multiple values on the as argument and return true for any. Any returns true if any of the values are in case of, so I told you everything is true or false, right? So any will return true if anything is true. So for instance, the list of numbers, if any number is non-zero, it will return true for any. And all will return true if all numbers are non-zero. If it's strings, if it's all strings are not empty and things like that, okay? Obviously, and you will understand that immediately, these depend on the size of the list that you have. The efficiency of these depends on the size of the list you have. And if the chance of having a zero in or a non-zero in is high or low. If the any has to wait until the element 1,000,000,100,023 to get a non-zero, it will take a while to get there. Okay? But for short lists, it's a very nice shortcut. So now something, what time is it? It's until 12, right? Yeah. So a small thing about variables that you have to remember, especially if you are programming in other programming languages, is that in Python, when you have a variable, especially a list or a dictionary or an object, if you are doing object-oriented, in fact, the way it works is that you have the memory of the computer. You have your list 1, 2, 3 here. And when you create a variable, what you do is you create a label that points there. So like this, okay? If I do that, here is the memory of the computer, and you have some spot where you have this. If I do b equals a, what Python does to keep the memory, to not fill the memory, is that it points also there, okay? So this means that if after that I modify some value of a, so here I do a1 equals 5, as you would expect, it modifies both a and b, okay? This I have to say because in many other languages, the default is to have copy variables. Here it's a reference system, and it affects many things. It allows to save memory, but on the other hand, it has some weird effects, like b now contains 153 because b points to the same thing as a, etc., etc. Okay. So one of the side effects of that is when does it work? When does it don't work? Doesn't work. So if I do that this way, sorry, an extra. So I do 1, 2, sorry, here. I do b equal a, so I find myself in this thing. Then if I do, after that, a equals 3, 4, the fact of using this equal sign forces Python to create a new object in memory. Okay, and then it does. So the effect that I talked about is broken when you have new assignment. So if I do that, then a and b don't point to the same thing anymore. And you can see it immediately. If I do a equals 1, 2, b equals a, b still points to 1, 2. But then I have done a equals 3, 4. So I've created a new object in memory with 3, 4, and a points that, okay, there, okay? So doing an assignment breaks the fact that you have the label thing that points to the same place in memory. And then the usual issue with that is that if you're using arguments in functions, the arguments in functions use this labeling system. So the argument inside the function will be a label to the same object outside the function. The classic is if I do def myfunc. So let's start from scratch. So I define a function that takes a list as an argument and changes the first value, the first element of the list to 3. So if I have a my list equals 0, 1, 3, 0, 1, 2, sorry. So my list points to 0, 1, 2. Then I call my function on my list. So let's put this into my function. I will have the mlist here, pointing to the same thing. So here I am in the function, and here I am outside, okay? And you see immediately that you have some weird effect because you have something that's inside the function that points to something that's outside the function. Which means if you modify mlist 0 equals 3, you will put a 3 here, okay? And this, if you are used to programming, means that you have some global variable behavior on something that you would expect to be local if you are not used to that effect. So you want to usually avoid that. And so if you are passing lists and dictionaries, for instance, as argument, you will try to avoid modifying them inside the functions, because then you modify an object outside. And for the user, it's not very easy to read and understand, and it can cause bugs because you usually want to separate the global scope that is outside your functions and the local scope which is inside your functions. Okay. So if you want your code to be readable, you will want to avoid that kind of behavior. Okay. There are many other examples, but this is the most useful one. So I want to present that. And again, as I showed before, if you do an assignment inside like this, so mlist equals mlist plus 3, then in that case, I will not have modified anything because I do assignment. So I go somewhere else in memory and then I modify. I don't modify it. This is modification. This is making a new spot in memory for mlist, which means that mlist points now to something completely local, which is 3, 1, 2, 3. Okay. So doing this assignment, as I said before, in this case, creates a new label and so breaks the name. So it's, I don't want you to understand it completely and integrate it completely, but just if you are starting with Python now, you have to expect that when you define your function, you have to think about this, especially if you are using functions, dictionaries, or object-oriented things as arguments to functions, okay? So a bit about modules and packages. So a module in Python is a set of objects like the library. So you will have functions, you will have objects, you have data in it. And for instance, you have the CSV to read CSV files. So CSV files, if you have never used them, is just a list of column files like Excel, for instance. And then you can import CSV. And then in this CSV module, you will have objects like reader. And so to access the reader object from the CSV module, you do CSV.reader. Okay. If I do help CSV.reader, it will give me the help about this object. If I just need the reader object from CSV, I can do from CSV import reader. And then I don't have to use the CSV dot because I have imported reader directly into my scope. Okay. You can also from CSV import everything, but this is supposed to be avoided at all costs because you will import things that you don't know how they are named, and they could have names that clash with the names that you have in your program. So it's better to use exactly what you need, and this is normal syntax. You can import reader, comma, something, comma, something, comma, something to import many things in one line. So it's super easy. The advantage in Python is that any Python file is already a module. So if I have a file called mymodule.py that contains a variable myvar equals sesi, and a function do something that's defined there, I can do from my module, if I am in the same folder, from my module, import my var, do something in any file. And then my var in my new code will contain cc and do something will do exactly this. Okay. So any file, any Python file that you have is already a module and you can import it, which means it's super easy in Python to have your function, your processing in one thing, and then the usage of this function in another one. You can do all your libraries, your personal stuff, your functions somewhere, and you just import them and it's okay. So the other syntax that I showed, so from my module, import my var do something, but I can also import my module and then call it with my module dot do something, and I will access the do something function inside the my module, which is just a file besides. Okay. If you want to make a package is a group of modules. Simply, you just make a folder, you put all your modules there, and to indicate to Python that it's a package, you create an empty file called __init__py inside the package folder. And then if I have a folder called my package that contains the init file and then a first module.py and a second module.py, I can do from my package import first module, second module, and then I can import, I can use variables or functions which would be in the first and the second file. Okay. That's easy, which means also if you have a very big code, then you can put things into different folders to access them depending on what you need. It makes your syntax readable. So an example of usage, CSV. So you have two kinds of modules in Python. You have hundreds of modules that are already included in Python distribution that you don't have to download or install. And then you have user packages, which are outside, that you can easily install. My package management system of choice at the moment is Anaconda, which means if you work on Linux, you have apt or yum or dnf to install package. Basically, Anaconda works the same way. It allows you to import Python modules directly into your environment and maintain a specific environment for you that is personally attached to yourself with the modules that you need. And it also allows you to define the various environments for your various project if you need different versions of software. Okay. So in this case, the CSV, I import CSV. Then I open a file that is normal opening of a file. It has nothing to do with CSV. Just I call it CSV file, but it's I don't care. And then I use CSV the dict reader, which is simply the way the CSV package reads the CSV file. And then I can loop on all the files in the reader, and it will return a dictionary for each line of my CSV file. So if I have several rows about animals in my case, then the first one has two columns. The file has two columns, animal and toy. It takes the keys from the first line naturally, and so I will have animal dog, toy bone, and animal cat, toy ball for the cat. Okay, it reads line by line. It puts that for row in reader. It puts that in a dictionary that's called row. And if I print the row, I just get this dictionary. Super convenient. And you see, I'm reading a CSV file, so that's an Excel file with two columns, with column names and stuff. And basically, just it in one line, which is just this. This does all the heavy lifting to have the file properly read, put into dictionaries, and accessible in an easy way for me. It's very convenient. That's one I use quite often too. And if you want to write a CSV file, instead of CSV.dict reader, you use dict writer. You have to give the names of the two columns, and then you write the row, and you give dictionaries in that case, so that it will put things at the right place. There's also a writer that is not a dict, and then instead of dictionaries, you give lists. That's super simple. I've written the thing, and it's just. Okay, so I talked about Conda before. This side is about pip, which is another way of installing new packages in Python. The thing is, pip is getting less and less usable because it lost the search function which was super useful in the past, but disappeared completely because it became unusable. So you may want to use conda instead of pip now. I should change this slide because my preference has moved to conda recently. Use comments like in any normal programming language, but if you want to do things properly, you can use a special string that you put just below the definition of a function or an object in a class or so, and it will be used directly when you use the help on that object. So here, I define a function, then I have this, which is supposed to be the help about this function. And then if I code help, it will show directly this string. So if you are defining if you are writing program that has to be used by other people, then you should always assume that what you write will be used by other people, because you in 3 months is another person. Okay. If you have to get back in this code in 3 months and you haven't worked on it, then you will have forgotten most of your stuff, and then you need to have things explicit. So if you do that, you call the help and you get that back. If you write it well, then you always get the help in. Okay. You can also, and that's debatable, but in many cases it would be useful to have, you can have self-tests, which are tests which are done to test that functions do whatever they are supposed to do. If you write code that has to be reliable on a long term, then you want to include self-tests to ensure that when you do a modification somewhere on the code, you don't break the rest of the code, which can happen, obviously. And if you don't do that, then when you do a modification, you have to retest the whole code to check that you didn't include a bug, introduce a bug somewhere else, and you will always forget to test something. Okay. So this is useful. One way of using it is to use the mtest, the doc test module. There are several different ways. If you use this one, the easy part is just you have to write a text file which contains the input and the output, and then it will just compare that the output is what you expect. That's one way of doing things. I wouldn't recommend using that on big projects. If you use big projects, then you have to research a bit how to do it. But if your project is big and people will rely on it, you might consider having a test suite like that. Obviously, it's not always easy. For instance, if you have external output, if you rely on databases, if you rely on I don't know, the storage on the computing cluster and things like that, then it's harder to do. But think about it. Okay. Another one that I like quite much is the logging. So if you write code, you will most always use prints here and there to debug and to see if things are going well or not. One way of getting to the higher level of that is to use the logging module, which is already included in Python by default. And basically, it allows you to define a level of logging. So if you run a professional program, it should only show things on the screen when there are problems. So the logging level will be put on warning, and everything that is of the level of debug or information will not be shown. So if I have that, basic config level equals warning, then I call the warning function, then it will be shown. If I call the info function, it will not be shown. Okay, which means you can write a whole program with those lines. And then when you are developing, you set the logging level to debug, and you will get the full output. And when you are done and you are happy, you just have to change the logging level to warning. And then when the user uses it, then the level is warning, and all the info at debug are not shown, and user will be happy. Okay, you won't have to comment or remove prints here and there. You just have to change at the top of the file the debug level, and then you have everything. This really changes your lives if you are doing properly. And the basic config also allows you to put into a log file and things like that. So it has a lot of flexibility. If you define the things well, you can also send emails. We have some of these. So it's really flexible, but the basic usage, this simple usage, is already life-changing in many projects. That I skip for now. So this is the Zen of Python. It's basically what Python developers want you to think when you are coding, but this is scripted. Things are some things are easy, like explicit is better than implicit. So write the variable names instead of guessing the variable names. Simple is better than complex. If you can write 2 lines that are simple to read, that you could put in 1 line that's harder to read, just keep 2 lines because the user will be happy. Lots of things like that. But I understand like half of them, so I don't want to. And okay, and then what time is it? Oh, 15 minutes. It will be short. I really need more time. Okay, and the computer doesn't put this. So some modules that you might find useful, the sys module, which allows you to have Python script with arguments. The OS module, which allows to navigate the folder structures. You can do CD, you can create new folders, you can get the file properties, see if files are readable and stuff. So this is quite useful. Or operating system is quite natural name. Glob, which is quite nice also to get the list of files in a folder, for instance. You have argparse, which is an extension from this, which allows you to have a nice help for a program, and then help for each of the arguments of a program, that like what you have usually when you use a normal Linux program. Then in some useful things, you have the iter tools, which are a list of tools for iterating through objects. I put examples, but they are quite useful in general. Cycle allows you to go through a list multiple times, for instance, depending on what you need. You can chain several lists or other things that you can iterate on, like file descriptors and things like that. Collections is an improvement on the dictionary lists and stuff with some additional functions. Regular expression that I mentioned earlier allow you to not only look if a string is contained in another string, but write patterns. So like you can check if there's an IP address in a string, or if there's an email in a string and things like that. That's quite useful too.
And sorry, regular expression, is it like regex?
Yeah, that's exactly that. Yeah. So if you are used to regex in Bash or in Perl or any regex language, then you can use the syntax can be a tiny bit different, but very, very tiny differences. If you are comfortable with regex, it's a god given. But if you are using regex, usually you introduce no problems, because if the regex is complicated, it can be really true. Where is that? Yeah, it's exactly that. So some other utilities, the copy utility, it allows to avoid this completely, because it allows to make a copy of an object instead of referencing the same object. So if you want to avoid that and you don't know how, you can use copy, but be aware that you will have 2 exact copies of the same object. If the object is big, then you have 2 times the memory. Okay. You have time, which allows to manage date and time objects, convert them, format them. It allows to sleep if you want to sleep. I don't know. There are some cases for tests and things like that. JSON and Pickle allow to take Python data and move it into some text format. So Pickle allows to take any object and any Python object and transfer it as text, as a string. You can save it in a file and then import it, and you import the exact Python object with all its features. Okay. JSON is more like a dictionary format that comes basically from JavaScript, but it's now the standard to save data on all web data that you would get. And talking about web, you have requests, which is a way to access a website and get the data from there. That is super useful. So because now we are in the world of APIs, of open data and stuff, and with requests you can just fetch things from the web and read them directly. So for science, the most useful ones are NumPy for linear algebra, so matrices and stuff, Matplotlib for plotting. There are several plotting libraries in Python, but Matplotlib is still dominating. SciPy contains all optimization, differential equation, integration, every single iterative methods and stuff, some statistics, some AI and stuff. So very useful too, depending on what you want to do. And pandas is the basic data analyst stuff. So basically you give it data, it transforms it in what we call data frame. A data frame is an object in Python where you can do database-like queries. So you can filter, you can join, you can do things like that, which allow you to clean up your data, for instance, in a very efficient way, and then transform it in a way that you want to use into a program. So I would say these are, if you have a program, if you have scientific programs and you don't have NumPy or pandas in it, you're not doing things